To a topic that's especially relevant as we kick off a new school year. High school CS programming.
Absolutely, it's a big one, especially for parents who, like myself, might not be familiar with the world of coding.
Totally. So today, we'll unpack exactly what this class entails, why it's more than just an elective, and how you can support your student, even if you haven't touched a line of code since, well, ever.
You're speaking my language. I've taken a peek at the syllabus, and it's definitely a far cry from the programming classes we grew up with.
Right. It emphasizes problem solving and logic just as much as the coding languages themselves, which I have to say is pretty impressive.
It is. It's about equipping them with skills that go way beyond the computer lab.
And speaking of coding languages, I see they'll be diving into Python this year. Any thoughts?
Excellent choice for a high school course. Python is known for being versatile and relatively easy to read and understand, especially for beginners. But here's the cool part.
Okay, I'm intrigued.
By learning Python, they're actually picking up fundamental programming concepts that apply to any coding language. Think of it like learning the grammar of programming.
Okay, that makes sense. So it's less about memorizing a specific language and more about developing that problem-solving mindset.
Exactly. They're building mental frameworks, which is invaluable in today's world. Now, the syllabus mentions creating interactive programs, even games and animations.
Really? Now we're talking. I remember mostly just trying to make text appear on the screen in my day.
Oh, I know, right? Things have definitely changed. But that's what makes this so exciting. Get ready for some impressive stuff. We're talking about using code to manipulate graphics, control animations, even build interactive stories.
Wow. Now those are some cool projects.
Right, and underlying all of that are core concepts like objects, lists, functions, loops, conditionals.
Okay, those are some fancy terms. For those of us who haven't touched a line of code since, well, ever, you can break those down a bit.
Absolutely. Think of it this way. Imagine you're teaching a robot to make a peanut butter and jelly sandwich.
Okay, I'm following.
Objects are like the ingredients and tools. The bread, the peanut butter, the jelly, the knife. Lists are like your recipe steps, telling the robot what to do in what order.
That actually makes a lot of sense. So what about those other terms? Functions, loops, conditionals?
Right. Well, functions are like pre-programmed actions your robot can perform, like spread or cut. Loops are instructions that tell the robot to repeat something a certain number of times, like spreading peanut butter on 2 slices of bread.
Okay, I see. And what about those conditional things?
Ah, yes. Those are like giving your robot decision-making power. If the jar is empty, then stop and ask for more peanut butter. See?
I'm actually starting to get this. So it's all about breaking down complex tasks into smaller, more manageable steps, just like we do in everyday life, Rick.
Precisely. And that's a key takeaway here. The skills students learn in this CS course, that logical thinking, breaking down problems, creating solutions step by step, those are applicable to any field, any career path.
Now, the syllabus mentions that students will be graded on more than just whether their code works. Can you elaborate on that? What else are they looking for?
It's about moving beyond just functionality and into design and clarity. Just like in a professional coding environment, things like how well organized the code is, how easy it is to read and understand, those factors play a big role. The syllabus specifically mentions something called commented code.
Commented code. Tell me more about that.
Imagine your child's code is like a well-organized recipe. The comments are like those helpful notes you jot down to remind yourself how you made something so delicious. It helps anyone else who might read the code, or even themselves later on, understand what each part does and why. It's about making the code user-friendly, even if that user is just your student a few months down the line.
That makes a lot of sense. It's about building those good habits early on. And speaking of real-world application, let's not forget the Python industry certification students have the opportunity to earn.
Absolutely. This is a significant advantage, especially for students considering a future in computer science or a related field. Imagine your child applying to college with a recognized industry certification under their belt. Talk about standing out.
So we've covered the why this course is so valuable, and touched upon the what, the kinds of skills students will gain. Now let's dive a bit deeper into the how. The syllabus breaks down the learning into specific units, each focusing on a different aspect of programming.
Right, it looks like Unit 1 jumps right into the fundamentals of computer graphics. This is where they'll learn how to command the computer to create visual elements. The syllabus mentions a resource called CMU CS Academy. It's fascinating how they've designed the curriculum to be so interactive and engaging. Have you had a chance to take a look?
I have, and one detail that really clicked for me was how they explained the canvas, the digital space where students create everything like a grid, with its own coordinate system using X and Y values. Remember those from our algebra days? Suddenly they have a whole new meaning.
It's a great example of how this course reinforces mathematical understanding in a really visual, hands-on way. Those equations aren't just abstract symbols anymore. They're tools for creating something interactive and cool. And speaking of visual, Unit 1 also introduces gradients and opacity.
Those sound familiar from, well, pretty much every design program I've ever attempted to use.
Exactly. These might seem like small details, but they're what make designs pop. Think about a website you love. The way the colors blend smoothly, the way some elements stand out more than others. That's all thanks to a thoughtful application of gradients and opacity.
It's amazing how these seemingly small things can make such a big difference. It sounds like Unit 1 is all about building that foundation in visual design principles, but using code as the tool.
Exactly. It's about giving your child a whole new way to express their creativity. And that creativity really comes alive in Unit 2, where they dive into mouse events.
Mouse events. So, like, what happens when you click or drag the mouse?
Exactly. Remember those shapes and colors from Unit 1. Now imagine your child being able to make those shapes move, change color, even disappear, all with a click of the mouse. They'll be writing code to tell the program how to respond to those user actions. It's where they start building truly interactive programs.
That's what I call bringing code to life. It's no wonder kids get hooked on programming when they can see their creations respond in such a dynamic way.
It's really rewarding to see those aha moments when the code clicks and their vision comes to life. And speaking of clicking, Unit 2 also dives into the crucial skill of debugging.
Ah, yes, debugging. Because, let's be honest, how often does code work perfectly the first time?
Rarely, if ever. Debugging is all about figuring out why something isn't working as expected and finding ways to fix those errors. It's like solving a puzzle, and in the process, students develop those critical thinking and problem-solving skills we keep talking about.
It's like that feeling of satisfaction when you finally solve a tricky riddle.
Precisely. And just like in those logic puzzles we all loved as kids, there's a real sense of accomplishment that comes from figuring out the solution.
Absolutely. Now, moving on from mouse clicks, it looks like Unit 3 introduces the concept of conditionals. Can you shed some light on what those are all about?
Well, think about how we make decisions in everyday life. If it's raining, then we grab an umbrella. Otherwise, we leave it at home. Conditionals in programming work in a similar way. They allow the program to make choices based on whether certain conditions are true or false.
So it's like giving the computer the ability to make decisions based on different scenarios.
Exactly. This is where things get really powerful because it allows for more dynamic and interactive programs. For example, in a game, the program can check if a player's score reaches a certain number and then trigger a new level or a special reward.
It's all about creating those if this, then that scenarios that make programs so engaging.
Precisely. And Unit 4 builds on this idea of user interaction by introducing key events. So now, instead of just responding to mouse clicks, the program can react to specific keys being pressed on the keyboard. Imagine your child coding a game where pressing the spacebar makes a character jump, or pressing the arrow keys controls its movement.
That sounds amazing. I can see how this opens up a world of possibilities for games and other interactive projects.
Absolutely. And as these projects become more complex, it's important to keep the code organized and manageable. That's where Unit 6 comes in, focusing on groups.
Groups, tell me more about that.
Think of it like organizing your kitchen. You wouldn't just throw all your pots, pans, and utensils into one giant drawer.
Definitely not. I'd never be able to find anything.
Exactly. In coding, groups allow you to bundle related shapes and code together, just like using containers to keep your kitchen neat and tidy. It's all about making the code easier to read, understand, and manage. And remember how we talked about commented code earlier? This is where those good habits really come in handy.
So it's like taking those organizational skills we try to instill in our kids in the real world and applying them to the digital world of coding.
Exactly. Now, Unit 6 also introduces a fascinating concept called step events. Have you ever wondered how animators create the illusion of smooth, continuous motion?
I always assumed it was a painstaking frame-by-frame process.
It can be, but in programming, we have step events that make things much more efficient. Imagine you're flipping through a flipbook. Each page represents a slightly different image, and when you flip through them quickly, it creates the illusion of movement. Step events work in a similar way. They allow the program to execute certain actions at regular intervals, creating that same sense of smooth animation without having to code each individual frame.
So instead of waiting for a user to click or press a key, the program itself can initiate actions at specific time intervals. That's impressive.
Exactly. It opens up a whole new realm of possibilities for creating dynamic and engaging animations.
It sounds like Unit 6 is a real turning point in the course where students start to grasp the true power and potential of programming.
It is. And speaking of power, Unit 7 delves into two more essential concepts: local variables and for loops. Now, I know those terms might sound a bit intimidating,
Just a tad.
but bear with me, they're actually quite intuitive once you break them down.
I'm all ears. Explain it to me like I'm back in high school, desperately trying to understand this stuff.
Okay, so imagine you're working on a big project, maybe building a model airplane. You've got all your tools and materials spread out on your workbench. Now, some of those tools are essential for the entire project, like your screwdriver or your glue. Those are like global variables in programming. They're accessible from anywhere in your code.
Okay, that makes sense. So what about those local variables you mentioned?
Well, imagine you need a specific tool for just one small part of the project, like a tiny paintbrush for detail work. You wouldn't want that cluttering up your entire workbench, right? So you keep it in a separate container and only take it out when you need it. It's kind of like a local variable. It only exists within a specific section of your code, like a function, and then it disappears once you're done with it. It helps keep things organized and prevents unnecessary clutter.
It's all about working smarter, not harder, even in coding.
Exactly. Now, let's talk about for loops. Imagine having to write your name on a piece of paper 100 times.
My hand cramps just thinking about it.
Well, for loops are like giving the computer a set of instructions and telling it to repeat those instructions a specific number of times. It's automation at its finest.
So instead of writing your name 100 times, you could write a for loop to do it for you.
Exactly. It's a powerful way to handle repetitive tasks and make your code much more efficient. And trust me, as projects get more complex, you'll be thanking those for loops. They're real time savers.
So they're learning to work smarter, not harder. I like it. What else is in store for these budding programmers?
Well, Unit 8 takes those for loops to the next level with nested for loops.
Nested for loops. That sounds intense.
It might sound complicated, but
Yeah.
think of it like organizing a recipe book. You might have different categories like appetizers, main courses, and desserts. And within each category, you have individual recipes. Nested for loops are similar. They allow you to create loops within loops, which is incredibly useful for working with more complex data structures. They'll also be introduced to new shape commands for arcs and arrows, which opens up even more design possibilities.
So they're taking those building blocks and creating increasingly impressive structures.
Exactly. And as they work with these more intricate programs, they'll start to encounter different types of data like integers, floats, strings, and booleans. Unit 8 introduces these concepts as well.
I have to admit, those terms are a bit fuzzy in my memory. Could you refresh them for me?
Of course. Think of it like this. Just like a good chef knows the difference between flour, sugar, and salt, a good programmer needs to understand the different types of data computers use. Integers are whole numbers, floats are numbers with decimal points, strings are text, and booleans are like true or false values.
So it's all about using the right type of data for the task at hand.
Exactly. And as students become more comfortable working with different data types, they can start to build even more sophisticated programs.
This is incredible. I'm learning so much. It's amazing how much goes into creating those apps and programs we use every day. It really highlights the level of detail and complexity behind those seemingly simple actions we take for granted in the digital world.
It's true. And that brings us to Unit 9, where things get even more interactive. This is where students explore text input and output.
So instead of just clicking or pressing keys, users can actually type in information and receive responses.
Exactly. Think about those chatbots you might encounter on websites or when ordering food online. This unit gives students a taste of how those systems work. They'll learn to write code that can take in information from the user, process it, and then display meaningful results back to them.
It's like they're giving the computer the ability to have a conversation.
In a way, yes. It's all about creating those dynamic back and forth interactions that make technology feel more intuitive and responsive.
That's impressive. Any other surprises in store for these students as they wrap up the course?
Units 10 and 11 introduce even more sophisticated tools for managing data. Imagine going from that single kitchen drawer we talked about earlier to a well-organized pantry, complete with labeled containers for different ingredients. That's essentially what they're building with concepts like lists and to-do lists. They're learning to wrangle and organize large amounts of information efficiently, which is a valuable skill in any field that deals with data, which, let's face it, is most fields these days.
It's incredible how much ground this CS programming class covers in just 1 year.
It really is. And remember, we've just scratched the surface. The real magic happens when these concepts click for your student and they start to apply them in their own unique ways.
And speaking of applying what they've learned, the syllabus mentioned a final project. What can you tell us about that?
It's their opportunity to shine. They'll be designing and building their own interactive program from scratch, bringing together everything they've learned throughout the course. It's their chance to showcase those design skills, that problem-solving prowess, and all those creative coding chops they've developed.
It sounds like a fantastic way to solidify their understanding and gain some real-world experience.
Absolutely. And remember that industry certification we discussed, this final project will be excellent preparation for that exam. Imagine your child ending the year not only with a portfolio of impressive coding projects, but also with an industry-recognized credential. It's a remarkable accomplishment.
This deep dive has been incredibly insightful. I have to admit, I had no idea high school CS programming was this comprehensive.
It's come a long way. And the most exciting part is this is just the beginning of their coding journey. Who knows what amazing things they'll create with these newfound skills.
So to our listeners, as your student embarks on this exciting adventure into the world of programming, remember to stay curious, ask questions, and most importantly, have fun along the way. You might even be surprised by how much you learn yourself.
I second that.
And on that note, we'll wrap up this deep dive. Thanks for joining us as we explore the ins and outs of high school CS programming. Now, before we go, one final thought to ponder. How can you, as parents, create an environment at home that encourages this kind of computational thinking, even if you're not a tech person yourself? Simple things like logic puzzles, building games, even just talking about how technology works, can plant those seeds of curiosity and set them on a path to becoming true digital creators.